Despite mandated improvements in confined space entry procedures, accidents still occur.
Hey, can you hear me? You okay?
Supervisors may fail to see that employees comply with the organization's procedures for safe entry. Conditions may arise that were unanticipated during the preparation of the permit. Hazards may appear suddenly and without warning, or a space may be entered where the participants are unaware of or unwilling to comply with mandated procedures. When an accident occurs, properly trained attendants and emergency teams can respond quickly and safely. However, rescuers must not enter the space unless they are trained and equipped to do so, and have taken appropriate precautions.
Confined space entry is probably the most hazardous type of work that you can do in an industrial workplace. In order to do this, once again, federal government requires that there be a written program. Inside that written program, the employer breaks down the three different classes of employees as defined under federal law. Those are the entrant, the person that goes in and performs the work or service; the attendant, the person who's required to be outside, who oversees the employees inside doing work and monitors them to make sure that they're not being overcome or having problems in the space. The third category of employee is that of the entry supervisor. It's the entry supervisor who fills out the paperwork, oversees the safeguarding of the employees, and then signs the permit authorizing the entry to begin. There are two different types of confined spaces. There are permit required and permit not required confined spaces. Additionally, we will talk about other items like controlled spaces. For all intensive purposes, we simply need to understand that what could be a confined space to one class of worker may not require a permit and be called a controlled space under a different standard. The ones that come to mind very quickly are under 268, telecommunication standards, and 269, which starts to get into your electrical power transmission and distribution standards. And we'll take a look at those down the road. So how do we define a confined space, or how do I recognize a confined space? There are three things that make a space a confined space. Number one, it can be an enclosed area that is not designed for humans to continually occupy it. It has to be large enough that a person can get into it and perform some type of work or service. And it has to be an area that has limited or restricted means or openings for getting in or getting out that make it very difficult. So understanding that it takes these three things to make a space a confined space, when am I going to be required to pull a permit to do this kind of work? The answer is first of all, it must meet the same three criteria we just talked about. But then in addition to that, a permit-required confined space has to have one of these four hazards present. It has to have a potential for or contain a hazardous atmosphere. That can be potential like flammable liquids, flammable vapors, toxic vapors, or even too little oxygen. It can contain a material that could surround or engulf a person. Kind of like when we do trenching work, could it collapse in on them and bury them alive? If this happened inside of a tank or vessel with a liquid, we would call it drowning. It's still engulfment. The third limitation that's placed on it, it says that if it has an internal shape that could trap or asphyxiate you. And what we're talking about here is kind of like when we were children and we climb up a slide and slide down the slide. And then we turn around and try to climb back up the slide on the angled part. As you try to climb back up the slide, you can only get so far before your traction is lost, and then you slide back down the slide down to the end again. So what we're saying here is basically that we've got walls that slope down to a smaller cross-section that pose a significant risk to employees being able to get out under their own free will. The fourth one is kind of a catch-22. It said, or if it contains any other characteristic that is recognized as a serious safety or health hazard. This could be a lot of different things. It can be spiders, it can be snakes, it can be scorpions, it can be gears that are turning, moving parts where your clothes or your gear can be caught up in it and drag you into it. As we've already discussed, the difference between permit-required confined spaces and confined spaces In order to make a safe entry, we need to understand the 6 steps that are necessary to ensure our safety in a confined space. Additionally, we'll talk about 2 additional requirements that form a total confined space entry program as defined under federal law. So let's begin with the first step. The first step is being able to recognize a space as a confined space. Normally, this is done through signage. We have a nice little black and red and white sign that says Permit Required Confined Space, and when we see it, we know that we're about to enter it. But not all confined spaces are marked. We create some as we do work, for example, trenching. So if we're not able to recognize those basic criteria that make a space a confined space, we could find ourselves entering a confined space and putting ourselves and others at risk. Second step in this process would be preparation. Preparation takes on 3 phases. The first phase is preparing the entry team itself. This is accomplished at a pre-task briefing. At the pre-task briefing, we go over what the work is to be accomplished. We talk about each person's duties and responsibilities as part of that entry team, and we go over documents like MSDS sheets so that we understand the chemicals that we're using in there as well as chemicals that were stored in there. During that particular briefing, we probably want to talk about upper explosive limits, lower explosive limits. We want to talk about the physical signs and symptoms of overexposure to those chemicals so that everyone on the team is able to recognize them and terminate an entry at that point in time. The second phase of preparation takes place in the space itself. This is where we allow boilers to cool down to operating temperatures between 78 and 82 degrees. Or it could be when we wash a boiler out so that we remove any of the substances that are inside that could be toxic or caustic, or setting up some type of a ventilation system to air out that hazard or the problems that may be associated with it inside. The third form of preparation is where we go out and we gather all of the tools, all of the equipment that we need to perform the work and the service and ensure our safety. This is where our tripods would come into place, our harnesses, safety ropes, SCBAs if we're going to have an escape capability. All of these tools and all of this preparation at this point in time is directly pointed towards a safe confined space entry. The third phase of entry is what we call testing. Testing also has 3 phases. Of those 3 phases, you may only need 1, you may need 2, or all 3 may be required. So let's begin with initial testing. Initial testing is conducted when we first open up the space. Most companies establish a pre-testing criteria. At the Space Center, ours requires us to ventilate at 500 CFM for 30 minutes. So by doing that, we flush out any collection of gases that may be in there. Then just prior to the arrival of the testing team, we shut that particular ventilation system off. The rationale being is by doing this tells us worst case scenario that should a ventilation system stop at that moment in time, what risks are associated with that entry team. The second form of testing is what we call periodic testing. Periodic testing is testing that is conducted at various periods of times that are predetermined by the initial results of the test as well as how close we are to the lower exposure limits for that particular hazard. The one that most commonly comes to my mind is carbon monoxide. Carbon monoxide lower threshold, 25 parts per million. They do the initial test, we've got 20 parts per million. Well, it's still safe to enter, but we're within 5 points of reaching the lower threshold. So in this kind of a situation, I may want them to come back and test every couple of hours or every hour to make sure that that level is being maintained. In addition, I would probably look at putting some type of continuous monitor on the individuals so that should it spike, it would alarm and allow us to get them out without anyone being exposed. The third one is what we call continuous testing. The continuous testing can take place in 2 different ways. Number 1, you can require a person from the environmental health to stand by and monitor those instrumentation the entire time that a person's in there. That way, if it ever spiked or they ever reached a lower level for any of the hazards, it would immediately alarm and we could get them out. The other time that we would do that would be as if it was an IDLH environment. Maybe we had a tank that we had to inert with nitrogen so that we could do some type of a welding process on it, and obviously if something went wrong in there, we have to be able to get the people out, and this way we understand what the hazards are inside there at that moment in time. So this is the testing process. Everything that we've talked about up till now form the fourth one, safeguards. Safeguards are those steps that we build into our program or build into our permitting process that ensure the safety of everyone going in. The last or the sixth element of this process is the attendant. The attendant is probably the most overlooked individual of the entry team. Quite honestly, the person that normally gets tagged to be the attendant is the guy that's the newest one on the block. He's never done this kind of work, but he's part of this team, so we stick him out there so he can kind of learn it. Tragic mistake. The other side of that coin would be a person that is so large that he can't physically get in there. And so because he can't get in there, we can still use him outside in that role, so we make him the attendant outside the space. Once again, not necessarily the best choice. As we see, the attendant serves a vital role. He oversees the persons that are down inside performing the work or service. As he watches them or observes them from above, he's looking for signs and symptoms that they've been overexposed to a commodity or of changing conditions that pose a risk to those employees. The final step in the entry process is the entry permit itself. A lot of people do not understand an entry permit or how it's used. The entry permit, for lack of a better terminology, is a formal checklist. It puts in writing every step or process that was conducted to ensure the safe entrance and likely success of that confined space entry. It also affixes responsibility. Who authorized this entry to take place? What steps did he or she take to safeguard the employees before she allowed them to enter? Pretty critical. And like I said, it becomes the final checklist. So these are the steps that make up a safe confined space entry. We add to them a rescue provision, which simply says the ability to get them out, and I tend to look at this from what we call self-rescue. If you as a worker or as a technician are not able to get yourself out under your own power in a self-rescue role, then you're relying on a couple of things. Number one, rescue. If that rescue team is not outside, suited up, and immediately ready to enter when the incident occurs, or they're on standby back at a fire station, what you're talking about is how long is it going to take for them to get to you and get you out of that environment. Most of us know that you can have a problem, from lack of oxygen that will affect your brain in anywhere from 3 to 5 minutes, depending upon which standard you choose to believe. The American Heart Association, Red Cross, because together they both kind of fluctuate this. But what they do agree on is that there are two vital things that will extend or limit that time period. The first one, of course, is temperature. The higher the temperature or the ambient air that you're entering into, that window is narrowed. The same thing is true for the second element, which is the physical condition of the individuals that are doing the work. And in today's society, we don't have too many Charles Atlases that are doing confined space entry work, so I think you can see that either one of these tend to push us towards the bottom of that 3-minute window. And if we believe that we can make a call to a fire station, have a fire response team arrive at our location, determine whether or not the air is capable of being breathed, or dawn SCBAs and come and get us, I think who's fooling who. All of this tends to the last element in that entry program period. That's training. Training is the key essential crux of the whole process. Through training, each person understands duties, responsibilities, is able to affix what the liabilities are when he makes conscious decisions inside that space that could affect themselves or others. Training begins in the classroom, but it ends in what we call an OJT, out in the workplace, on the job, working in the spaces that you work with, dealing with the hazards that are unique to your individual trade or occupation.